welcome back to the EV Life podcast. I'm your host, Crystal.
And I'm Hannah Neal, the producer.
And in today's episode, we're going to be talking about a topic that we haven't covered yet on the podcast, electric vehicles, specifically in the aviation field.
Yeah, so we'll be talking to Erika Holtz of Harbour Air, which is a seaplane company based out of the Vancouver area. And I actually had the opportunity to hear Erika speak live at the Everything Electric conference early in September. And so I think it's a really interesting topic because Harbour Air is actually deploying the first commercial electric airplane in the world. And so I think there's a lot of cool innovations coming out of the aviation industry when it comes to electrification and the EV space. So, yeah.
Yeah, so Erika is going to share a little bit about how this initiative came about, that Harbour Air became the first company globally to deploy a fully electric commercial airplane. And she'll also share a little bit about the innovations happening in the industry. So I do hope that you'll enjoy this conversation. And as always, if you'd like to weigh in or if you have thoughts that you'd like to share with the community, you can do so in the EV Life group on the AMA mobile app. Enjoy the conversation. Hi, Erika. Thank you so much for joining me today on the EV Life podcast.
Thank you for having me.
Can you tell our audience a little bit about Harbour Air and what your role is there?
Absolutely. So Harbour Air is a seaplane operator on the BC South Coast, connecting the communities between Vancouver Island and the mainland. We've been servicing the coast for about 43 years, I think now. And my role has been in the engineering department. I've been leading their engineering certification and design team for the last 13 years. And since 2019, I have been the program manager and lead engineer for their electrification program. So 2019 was when our CEO at the time, Greg McDougall, announced that he wanted to electrify his fleet. And so we took the first aircraft, our DHC-2 Mark 1 piston eBeaver, and converted it to fully electric and flew it for the first time in December of 2019.
That was a big step because, to my understanding, no one else was electrifying airplanes. Is that correct?
Sort of. There's some projects out there, and there have been people working in the eVTOL, the electric vertical takeoff and landing market. So people like Joby and Beta and Lilium, there are a bunch of them out there. But nobody had been looking at the retrofit market of taking the existing aircraft and converting it to fully electric. And a lot of those programs require multiple layers of certification, so it's taking a bit longer. So our approach was to take an existing airframe that we already knew the characteristics of and simply changing out the propulsion to fully electric to try to advance it as quickly as possible.
So on the podcast, we've spoken to a few people who retrofit vehicles, cars, hot rods, and they retrofit it so that it is fully electric. Is it a similar process for the airplanes, or can you just share a little bit about what that process was like?
Sure. From a technology standpoint, it's very much the same, right? You take the combustion engine out, you take out the fuel system, any of the gauges that relate to that system, remove all that and replace it with a fully electric motor and inverters. We call it an engine because by definition, to get it certified as an aircraft engine, we have to call it an engine. I know there are a lot of people out there who will say, hey, it's actually a motor. Yes, I know. We've had to convert to calling it an engine for the authorities. And then also replacing the fuel system with a lithium-ion battery pack. And then, of course, all the communications and monitoring systems that go with that, displays, et cetera. So it's very, from a technology standpoint, very similar to a retrofit on an electric vehicle. From a certification and flight standpoint, it's quite a bit different. In order to be able to even just fly it experimentally, you still have to go through a process with the regulators to be offered a flight permit to fly because they want to make sure that you are de-risking as much as possible. You can't just, like an electric vehicle, you could probably take on a back road somewhere where there's nobody around and you could drive it. Can't do that with the aircraft, have to go through the process of getting a flight permit. And then in order to be able to sell the product to others or fly commercial passengers in it, we have to go through the full certification program.
So I know when you're retrofitting a car, one of the biggest, I guess, struggles is like the battery packs. They are quite heavy. So how did that affect the the airplane? Are they similar? Like, are they quite heavier than like a typical plane engine?
Yeah, the engine is lighter than the combustion engine. It has fewer parts in it, fewer rotating parts. So the engine is quite a bit lighter, but the batteries are quite a bit heavier than our fuel systems. The energy density is not there. And when compared to an electric vehicle, there are two things. One, we're having modules built that are aircraft specific. So people are paying a lot of attention to the materials that are used to make sure they are as light as possible. But also we can't afford to carry the liquid cooling. Most electric vehicles actually have a cooling system for the batteries that's liquid based, and we can't afford to carry the liquid on board the aircraft, or we wouldn't fit any passengers in. So our batteries actually have to be able to fly a mission without any liquid cooling. It has to do it with passive cooling only, or potentially some airflow. And then we're going to have to manage all the temperature issues, the rises and the differentials on the ground during charging.
Okay. Can you tell us a little bit about how these electric airplanes differ from traditional aircrafts in terms of like the range? Because again, that is a big topic that comes up when we're looking at cars. So is it a similar concern for airplanes? Do you get less range? Maybe just share a little bit about what that's like.
Yeah, the range is a problem. You talk about range anxiety in cars, it's going to be even higher in aircraft. The thing with aircraft, though, is when you have to look at the use application, right? Just because you could fit 5 people in an aircraft and 5 hours of fuel, we don't usually use them that way. So Harbour Air is a really good example of that use case. Most of our flights are 30 minutes on average. We don't climb to a really high altitude, so our energy usage is quite short. So even with the aircraft we're using today, we're using maybe a fifth of the possible fuel allowance that's able for the aircraft, because we simply don't fly them that far. So when you're looking at it is, okay, yes, you have a lot less range, but what do you need it for your particular use case? So for Harbour Air, we're looking at a half-hour mission plus reserve, and being able to carry somewhere between 4 and 6 passengers in the eBeaver. And with today's technology, we think we can achieve that. Other people probably won't be able to make the same use case. We're actively looking for wherever there are other use cases of it. Skydiving as another option that we've been looking at, because you climb up, people jump out, you go right back down. It's a 10, 15, 20-minute flight at most. So it would also lend itself well to what's available right now. The way we look at it is that we're at the worst case scenario for battery technology right now. And if we figure out how to get the product to certification, it'll only get better after that.
Can you tell me a little bit about what it would take to get the product to certification? How far away are we from that?
That's a really good question, and it's a difficult one to answer. There are various layers to that, because our traditional certification path doesn't really apply. It doesn't address all the potential fault and failure modes that could happen with this novel technology. So step 1 is getting the engine classified as an engine and certified under Part 33. That's where aircraft engines are certified. They're certified as a separate product. So MagniX out of Everett, Washington is working on that right now. The issue for them was always that Part 33 was written very specifically for combustion engines. It's for piston and turbines only. So they had to go through what they call a special condition process with the FAA. And that's where they wrote temporary regulations effectively within a special condition paper that just applied to the MagniX product. So they now have a blueprint to follow, but there's a lot of testing they have to do in order to get there. So they're probably a couple years out of getting to the type certificate for their engine. Then we have to take that engine and install it in the aircraft and certify that configuration in the aircraft. And that's the part that we're doing. We can do a lot of that work concurrently, but the validation work, which is fundamentally flight testing it with the conforming engine and batteries in it to prove performance, to prove flight characteristics, really can't happen until it's closer to the end of their program. So for us, we're thinking, we're hoping, targeting sort of like a late 2026 for certification, but that's a tough one to answer, since there are standards and regulations that aren't written for some of it. There's still the regulatory bodies from different countries haven't completely harmonized on how to certify a battery, for example, right? Like how do you trigger thermal runaway? How do you contain it? How do you mitigate it? What's the mandatory minimum level that we have to meet? And they haven't fully come to agreement on anything there that shows us what bar we have to jump over.
So, You kind of answered some of this next question I was going to ask, but I don't know if you can elaborate a little bit more, because I was going to ask, like, what are the biggest challenges right now in the electrification of airplanes? So it seems like certification is one, and then also kind of getting different countries on board and on the same page.
That's a big part of it. They are working on that. They have a team between Brazil, the FAA, Transport Canada, and EASA over in Europe. They have a team working on that, trying to ensure we're harmonized, because we don't want to have one country certifying to a different standard than a different country. We do want it to be harmonized, and they're actively working on that. And I think they're making good steps. But it is a very slow process to A, understand the novel technology, B, figure out what the testing should be, and then C, get everybody to agree on it. So that's one of the biggest challenges. The other big challenge is, of course, the battery technology. It does still need to advance to be able to be adaptable for more than just our use case.
So how soon are we going to see electric planes for bigger airlines?
That is an excellent question. And I think it's really... It's necessary for us to really describe the fact that what we're doing right now is the baby steps, right? The first steps. We have to learn how to certify an electric engine and how to certify fully battery electric components, because they will be used in the larger aircraft as either a hybrid configuration or use an electric engine with a battery with a hydrogen system. So it's really the nucleus and the stepping stone so that it can be scaled up to the larger aircraft. I think it is something we'll see in our lifetime, hopefully. But it's still a number of years away. I think we're a few years away from getting our technology really out there with people able to use fully electric aircraft of our size of 6 to 9 passenger. And then you're in the 10 plus years, I think you could see some adaptation of that up to the sort of the 50-seat aircraft, whether in a hybrid or a hydrogen configuration. There's so much work going on in this sector that it's really exciting. And I think there's something going to come up in that larger aircraft category really soon.
Thank you. Is there anything that you'd like to share with our audience in terms of trends in the aviation space right now that we haven't already covered?
Sure. It's a really exciting time to be in aviation. I've got a lot of people on my team who are nearing 70 years old working on it, because it's been decades since they've had something truly novel to work on. And so it's an opportunity, in the face of so much pushback on flights and flight shaming. It's an opportunity for young people to become involved and help change and shape the aviation industry to make it a better place.
Well, Erika, this was such a lovely conversation. Thank you so much for joining me on the podcast.
Thank you for having me.
Thank you so much for joining us for another episode of the EV Life podcast. Make sure that you're subscribed so you never miss an episode. And if you'd like to join the conversation, you can always do so in the EV Life group on the AMA mobile app. We'll talk to you in the next episode.